Hello students, welcome in physics class. Today we are going to discuss some numericals, solve numericals of chapter number 6, heat transfer. Now look at that example number 1. So calculate the increase in length of an aluminium cable of length 30 meters. This is the original length when temperature rises from 15 degrees Celsius to 45 degrees Celsius. So this is the original temperature, and this is the final temperature. Initial and final temperature. Given that coefficient of linear expansion of aluminium is 2.4 into 10 to the minus 5 per degree Celsius. So all the values are given. So look at that. Original length of cable, that is L equal 30 meter. Initial temperature T1 15 degrees Celsius, T2 45 degrees, that is the final. So given the value of alpha 2.4 into 10 to the minus 5 per degree Celsius. Now change in temperature, that is rise in temperature, you can say that T2 minus T1, 45 minus 15, that is final temperature minus initial temperature. So it is equal to 30 degrees Celsius. As we know that change in length or increase in length equal to L alpha delta T. Put all these values. So 30 multiply 30, 2.4, remove this decimal, 224 by 10, multiply 10 raised to the power minus 5. Now look at that. 33 are 90, 24, multiply 24, multiply 10 minus 5, again multiplied 2060, and here 2.16. We put the decimal after 3 digits, 1, 2, 3, that is 2.1. So here the power will be increased by 3. So minus 5 plus 3, that is 10 to the minus 2 meter, and as we know that 1 centimeter equal to 10 raised to the power minus 2 meter. So delta equal to 2.16 centimeters. So this is the increase in length. Look at second example. An iron sheet. This is iron sheet is 5 meter long and 2 meter broad. So here 5 meter is the length of the sheet and 2 meter is the breadth. It is heated through 60 degrees Celsius. Calculate the change in surface area of the sheet, and coefficient of superficial expansion of iron is 2.4 into 10 minus 5 per degree Celsius. So all the values are given. So look at that in the form of sheet. This is the iron length 5 meter, 2 meter. We will calculate the area, and as we know that area equal to length into breadth. So 5 into 2, 10 meter square, and delta T given 60 degrees Celsius, beta also 2.4 into 10 minus 5 per degree Celsius. As we know that increase in area equal to A beta delta T. So put all these values, given values. Now look at that. 10, remove this decimal, 24 by 10, multiply 60 and multiply 10 minus 5. So multiply these values and we will get 1440. Again put the decimal after the 3 digit, 1, 2 and 3. So 1.4. So here the power will be increased by 3. So minus 5 plus 3, that is minus 2 meters. So increase in area is 1.44 into 10 raised to the power minus 2 meters square. So look at the third example. One a copper cube or side to 20 centimeter is a heater. So here copper is in the form of cube. 20 centimeters is heated from 0 degrees Celsius to 100 degrees Celsius. So rising temperature is 100 degrees Celsius. Its volume increased by 40 centimeters. So volume is given. What is the increased volume? That is 40 centimeter cube. Calculate the value of volume expansion coefficient of copper. So here we have to calculate the value of the gamma. So now look at that in the form of cube copper. So length, breadth, or you can say length, breadth or height, all are equal. So side given, that is equal to 20 centimeter. As we know that volume of the cube, side cube, that is 20 centimeter whole cube. So it will become 8000 centimeter cube. And look at that rise in temperature delta T 100 minus 0, that is equal to 100 degrees Celsius. So rise in volume given, that is 40 centimeter cube. As we know that gamma equal to delta V over V multiply delta T. So put all these values. 40 divided by 8000 multiply 100. Now look at that. Here 3 zeros, 2 zeros, that is 3 plus 2, 5 zeros. That will become as like that, 10 raised to the power 5. So 40 over 8. So divided it. That will be the 5 into 10 raised to the power. Look at that sign. Sign will be changed in the numerator, that is 10 raised to the power minus 5. So 5 into 10 minus 5 per degree Celsius. This is the cubical expansion, value of the cubical expansion. Now the last one. So example number 4. Here given the coefficient of linear expansion of steel 1.1 into 10 raised to 5 minus 5 per degree Celsius, and we have to calculate the superficial expansion and coefficient of volume expansion. So it is quite easy. So look at that, value of the alpha is given, and as we know that relation between beta and 2 alpha, that is beta equal to 2 alpha. So put the value of the alpha, it will be 2 multiply 1.1 into 10 minus 5, and it become 2.2 into 10 minus 5 per degree Celsius. And similarly gamma equal to 3 alpha, so it is 3 times the alpha. So put the value of alpha and we will get 3.3 into 10 raised to power minus 5 per degree Celsius.